name is Debanik Purkayastha. This is Mastering Electronics Lab 2. We are designing a Wheatstone bridge circuit. So here's a picture of the circuit. So Wheatstone bridge has the property to measure unknown electrical impedance and measuring small changes in resistance. If we follow the circuit, here's the function generator. It's connected to resistors, which we've marked with values of 1.8 kiloohms, 2.9 kiloohms, 1 mega ohm, and then 2.2 kiloohms. It's also connected to a potentiometer. So when we run the wave gen and generate the signal, so we'll start by running the wave gen at a frequency of 1 kilohertz and peak-to-peak voltage of 10 volts, so an amplitude of 5. And here we have our input for channel 1, which is connected right here. It's connected. This is channel 1. And then here is channel 2. And then we're going to be calculating the difference between C1 and C2. We can adjust the resistance of the potentiometer using this screwdriver by placing it here. If you watch the effect of the orange line, which represents the distance, as I turn the potentiometer, it either increases or decreases to show increases or decreases, indicating the difference between the two channels. And the goal of this lab was to find a resistance which would minimize the difference. So we found that to be about 4.7 kiloohms, which we measured after we disconnected the potentiometer. So the goal of this lab was to find the minimal value of the resistor that would minimize the difference between C1 and C2. So what we did is we replaced the resistor with we replaced the potentiometer with actual resistors, and using the measured resistance that we found with the potentiometer, we used actual resistors to replace it, and the goal was to minimize the difference between C1 and C2. One thing you'll notice is that this difference curve is very noisy, so the way that we smooth it out is we go to this average button right here, and we can increase it to about 20, which should, when we rerun it, smooth out the graph even more. So yeah, that's how we smooth out the noise generated by this curve.